Hello everyone, welcome back to my channel. I want to say a big thank you to everybody that has watched my last video on index number. There are a lot of views right now and more people are already subscribing. I say a big thank you. I've not taken any of these privileges as right. I'm grateful for everyone that has seen the video, that has watched this, that has learned one or two things from the video. I'm also grateful for the comments, the questions that are coming in, and I'm praying to keep improving, and as you watch I know I would also keep improving. Today we have another topic before us, and the topic is called chi-square distribution. Don't forget that my name is Dr. Bisael Otokiti, and I'm always super excited to be in front of the camera now. But before now I was somehow timid, but now I'm getting brighter and bolder in front of the camera. So come along with me as I take us through the journey of chi-square distribution. Many people say chi. It's not chi, it's chi-square. Chi-square distribution. When we're growing up, there's something we used to call kites. We don't say that thing, we don't call that thing kites. It's kites. So this is chi-square distribution. Chi-square distribution. It's not chi, it's chi-square distribution, and that is what we'll be looking at today. It's also a statistical tool that is useful in the 21st century, though there are more advanced method that has overtaken chi-square, but we still take or teach chi-square for the basis, for basic knowledge for people to understand the other statistical instruments that are more advanced now, because this is the basis of all those other statistical instruments. So we look at chi-square and distribution. One, what is a chi-square distribution? A chi-square distribution is mostly used to see whether a frequency distribution fits a specific pattern, and somehow we have been using it for ages now. In some advanced country it is getting outdated, but in Nigeria we still use it for research, we still use it in statistics, we still teach it anyway, and it's still very useful. So it is a useful sampling distribution that starts with 0 and is always skewed with a long tail to the right. It is always a right skewed test, and it starts with 0. Don't forget that when we did for hypothesis could be skewed to the right or to the left, but a chi-square is always a right skewed test. It is always to the right. It starts with 0. There are no negativity with chi-square. You know, for hypothesis testing we can have minus sign, we can have to the right, to the left, we can have a two-tailed test, but for a chi-square distribution it is always a right-tailed. It is always skewed to the right. It is always a right-tailed test. No left tail, or it's not a two-tail. It is always a right tail to the left, and the point of origin is always starting from 0. Then what are the important situations of a chi-square distribution? There are 3 most important situations. That does not mean there are not other situations, but these are the 3 most important situations. And one, why chi-square? One is to test the discrepancy between the observed variable or frequency and the expected variable. As we do example, you understand what observed and what expected frequencies are. Then also is to test the goodness of fit. If our time permits, in this same video we'll do an example on goodness of fit. We'll do maybe two example on chi-square and 2 example on goodness of fit, for us to know the difference between chi-square and goodness of fit. Just a slim difference, just a singular difference between the two. Then thirdly, to determine the association between 2 or more attributes. What is the relationship, what is the effect, what's the impact between 2 or more variables. Then what are the characteristics of chi-square distribution? Like we said, no negativity. That's the fourth characteristics. There are no negative signs in chi-square distribution. It is only positive sign, and it is always skewed to the right. Then 1, it is not symmetric in nature. Symmetric is a specific I'm trying to exact pattern, or an exactly the same pattern over a period of time or something. I'm trying to see the meaning of symmetric. I tried to Google it before this class, but I can't picture what it exactly means right now. So 1, it is not symmetric. Then 2, the shape depends on the degree of freedom. It means the degree of freedom determines, as we go on, you understand what degree of freedom means. Like in our last example, we tried to explain a little bit, but the shape depends on the degree of freedom. Then thirdly, as the degree of freedom increases, it becomes more symmetric. The higher the degree of freedom, the more symmetric it becomes. The lesser the degree of freedom, the less symmetric it becomes. Okay, we'll look at some of the examples or questions situations where we can use the chi-square distribution, and these are some of the examples and the steps of solving a chi-square distribution on the board. The first example says a producer of fragrance, perfume, body spray, roll-on might wish to see whether their customers or consumers prefer a particular scent of fragrance to the other. For somebody like me, if I'm buying ice cream, let's say a producer of ice cream wants to know, for somebody like me, I can only take vanilla. Any other ice cream that is, whether chocolate is added or strawberry or any other fragrance, I cannot take it. I prefer vanilla, and some other people cannot take vanilla because of their preference. My own preference is vanilla. So different people have different preference. Some people can take anything so far it's ice cream or so far it's fragrance, once it smells very nice. So depending on the fragrance, so many producer or manufacturer want to see whether customers or consumers have particular preference for a particular set of the commodities or the items or the products that they sell, so that they can make more of those products or activities. Let's say, for example, a manufacturer of bags or shoe may wish to see if a customer show preference for a particular color or design. For many ladies, black is one color that most ladies have, a black bag. But unfortunately for me, I don't like black. I don't know why. Maybe because I'm dark, so I don't like. It's not as if it's against any principle. But recently, somebody gave me a black bag, and I'm enjoying it. I take it to church in the morning, in the evening. It's very easy to carry. So I didn't know that before. But so we want to see if there is any preference. A customer shows preference for a particular color or design. Like I said, my own preference now, one is I can take blue, brown, but now I have a black bag. So why are consumers testing if customers or their consumers prefers a particular, so that they can concentrate on that design or that color? They will know and produce that color more. What if I get to a store where they are selling bag? I want a blue bag, and there is no blue bag. They have green, they have pink, they have wine, and I don't want any of that. So if customers or manufacturers, rather producer or manufacturer, know beforehand that consumers, so they prefer this particular color, they will make that color more and also market that color more, so that it will get to the final consumer. Then lastly, another example, a bank manager may wish to know which of their services is most sought out for. I'm not marketing for GTB, but I know the star 737 code is one of the most sought out software or system or transaction code for GTB. I know some other banks as there. I know Access Bank is star 901#. I've used it a couple of times and it has been fantastic. That 737 has also been wonderful. So a manager may wish to know which of their services is most sought after, so that they can put effort into that services, so that they can develop things that are similar or that are more unique, that people and their customers can enjoy. Okay, looking at the steps now, the first thing is we write the hypothesis out in word, or we write out the hypothesis. It's supposed to be hypothesis, not hypothesis. Hypothesis, it has to be plural, not singular, because we have the null hypothesis and we have the alternative hypothesis. In the last video, you can understand what hypothesis means better. It will be on top so that you can watch it. Write out the hypothesis, or write out hypothesis in words. Then also the second step is the degree of freedom, and the degree of freedom means row -1, then column -1. Everybody knows when we are talking about rows are in horizontal. 1, 2. These are row 1, row 2, row 3, row 4. Then column 1, column 2, column, and like this, 3 and 4. Vertical. I don't know if I'm changing it for one another, but I know rows and columns. So then The third step says compute the test value. Compute the test value, and the formula for computing the test value is chi-square. This is the short form of writing chi-square. Chi-square is equals to, this is summation of observed value minus expected value, then square root, abi in square, not square root, squared or square then divided by the expected value. The last step is make a decision, and in making a decision we have, when chi-square calculated is greater than chi-square tabulated, we reject the null hypothesis and accept the alternative hypothesis. When chi-square calculated is less than chi-square tabulated, we accept the null hypothesis and reject the alternative hypothesis. This decision making process is the opposite of the last video we did. You can check the link below for the last video on hypothesis testing and how we got everything there and like that. So the last after this step, then we can also draw the graph that shows a right tail test. Don't forget that we said the chi-square is always skewed to the right. It is always skewed to the right, and it's starting from the point of origin, which is 0, and it is always a right-tailed test. It is always to the right. Okay, this is a simple illustration to help us to understand what the chi-square distribution means and how it is used and how you can work it out, and how you can also help yourself with this video to solve other related problems when it comes to chi-square distribution. Illustration 1 says, suppose a market researcher wishes to see whether consumers have any preference among 6 colors of bags. A sample of 126 people provided the following data, and it means the consumers have preference. Actually, we have black 35, we have white bag 14, blue bag 23, yellow bag 20, red bag 16, green bag 18. These are the preference of the consumers. Then how do we get this solved? This is not the working. I would tell us how to work it because I've written the steps out earlier on, but this is just a quick or brief introduction to us to understand the concepts clearer. The first thing we need to note, as we can see here, that I wrote notes. If there were no preferences, imagine there are no preferences. The first thing we need to know, for every chi-square distribution, there are 2 things we need to find out: the observed frequency and the expected frequency. The observed frequency is their preference, that each of these customers or consumers have preference. Like I made an example earlier on ice cream. My preference, most preferred, preference upon preference upon preference. If you ask me any day, if you wake me up from sleep, if you want ice cream, what is your preference? It's vanilla or nothing. And some other people are also like that. I don't know what your own preference is. You can tell me your preference in the comment section below so that I would respond to you. I would send you a comment back. Okay, so one thing we need to know, that for a chi-square distribution, the observed variables are always given. The observed variable are always given. Our work is to work out the expected variable or frequency, then work out the formula, put it into the formula and work it out. Note that the observed variable are always given, whether by writing it out or by figures or by count or by any means. They would always give you the observed variable, what people's preference are, or what they are thinking their preference would be. Your own work or your own duty is to work out the expected frequency, and that is exactly what I've done on the board. I said the first thing to note is that if there were no preferences, imagine there are no preferences among these 26 people, it means everybody would have, the colors of bag will be equal. The manufacturer will produce, it is 126 and we have 6 colors, so it means the manufacturer will just say 126 divided by 6 colors. 126, 6 in 12, 1, 6 in 6, 1, 6 in 12, 2, then 6 in 6, 1, that's 21. It means for each of those colors, the manufacturer will produce black 21, white 21, blue 21, yellow 21, red 21, green 21. But because there was preference, the customers or the consumer had preference, and since they had preference, this is their preference. Most people preferred, from 126 people that we took a sample of, 35 of them preferred black, 14 of them preferred white, 23 of them preferred blue, 20 of them preferred yellow, 16 of them preferred red, and 18 of them preferred green. That does not mean they will not like any other color, but their first choice is what we have written on this board. So if there were no preference, you would expect each color to be selected with equal frequency, and that was how we got our expected frequency since the observed frequency were given. So how do we get our expected frequency? What we do is adding up all the values. They have already said 26 people, so 35 plus 14 plus 23 plus 20 plus 16 plus 18 will give us 126, divided by the numbers of colors that we have, 6 colors of bag, that is 21. So that is approximately 21 people will select each color, or the manufacturer will provide 21 pieces of each of the color. Then since the frequency for each color were obtained from a sample, these are called actual frequency, and they are called observed frequency. Let's forget, since the frequency of each color were obtained from a sample, like I said, the observed variable would always be given either from a sample or from a population or from a particular percentage of figures that have been taken, of people, or a random sampling of one thing or the other. Sometimes it might not be bags, sometimes it might be food, sometimes it might be fruits, sometimes it might be fragrance, sometimes it might be even choice of trainers. Is it Nike we prefer, or Puma, or there are different designs, or ASOS, or different designs. So then the last one says the frequencies obtained by calculation are called expected. So there are two things we need to watch out for in chi-square distribution. The first one is called observed frequency, and the second one is called expected frequency. And from this question, the observed frequency were already given: 35, 14, 23, 20, 16, and 18. Then the expected frequency, like I said, how did I get it? Adding up all these values together, dividing by the total number of colors, which is 6. So 35 plus 14 plus 23 plus 20 plus 16 plus 18 will give us 126, divided by the number of colors, which is 6. 126 divided by 6, that is 12. 6 in 12, 2. Then 6 in 6, that's 1, that is 21. And this is the way, this is how I got 21 for each of the expected variables. Then we move into action now in solving this question. Okay, the solution now, like I said earlier, that for every chi-square there are 2 hypothesis testing. We have the null hypothesis and the alternative hypothesis. For the null hypothesis, we is always stated in the negative form, and we have consumers do not have preference among the 6 colors of bag. Then the H1, which is H subscript of 1, consumers have preference among the 6 colors of bag. Then the second step is the degree of freedom, and degree of freedom for chi-square, we have degree of freedom for chi-square, we have the degree of freedom for goodness of fit. I'll also do an example on goodness of fit, but now is for chi-square. Then degree of freedom says K means, no, it is not even K, it is R minus 1. It is R minus 1, then C minus 1. R means row, and C means column. How many rows do we have? 1, 2, 3, 4, 5, 6. So it means 6 minus 1. 6 minus 1 into brackets. How many column do we have? How many column do we have? I don't want to assume that we have one. Let me just assume we have 2 columns. 2 columns. So this will be 2 minus 1. 2 minus 1. So this will be, the answer will be 5. 6 minus 1 is 5. 5 into 2 minus 1 is 1. And that's our answer is 5. We would also need our table here. Like the last video, I did a how you can get the table on the last video. The same I'll do for this table. So let me get my table so that I can show you what. Okay, like we did for the last class, this is also a table on chi-square distribution. And don't also forget that for this degree of freedom, our level, significant level is 5%. Our significant level is 5%, and 5% is equals to 0.05. 5% is equals to 0.05, and our degree of freedom is equals to 5. So what do? We come on the table. The first column is the degree of freedom, and it is numbered 1 to 100. You have it on the slide on the video so that you can make use of it. The topic is chi-square distribution, area to the right of a critical value. You can also download it. You can see it online. You can see it at the back of most statistics textbook, in case that one on a video is not so clear for you, but I'm sure it will be clear for you to use it. Then you come to the first mark, or the first figure on this is 0.995, then 0.99, 0.975, 0.95, 0.90, 0.10, 0.05, 0.025, 0.01, then 0.005. But since my level of significance is 5%, and 5% divided by 100 will give us 0.05. So I come to where 0.05 is and trace it to a degree. The degree of freedom is 5. Then I trace it to where 0.05 is. On this table, the degree of freedom is 5 and my significant level is 0.05. The answer is 11.071. 11.071. We can also say it is 11.1, 11.071, or 11.1. The third step now, looking at the third step says compute the test statistics. Compute the test statistics, the test value, or the test statistics. And our formula of chi-square is what? Summation of observed minus expected squared, summation of observed minus expected squared all over expected, summation of observed minus expected all over expected. And that is what this table is for. I will quickly run the analysis on the table now so that everybody can see. We have, these are frequency. We have black, we have white, we have blue, we have yellow, we have red, and we have green. Then our observed value 35, 14, 23, 20, 16, 18. The total is 126. Then the expected value is also 21, 21, 21, 21, 21, 21, 21. Adding it together, we have 126. This next column says observed value minus expected value. It means 35 minus 21. 35 minus 21. What do we have? We have 4 and we have 1, so 14. 35 minus 21 is 14. Then this is saying observed minus expected squared. It means 14 times 14, and 14 times 14, 14 times 14, 4 times 4, we have 6, remaining 1, 4 times 1, we have 4, with this one making 5, 4 here 4, then 4 here 1, we have 6, 196. Our answer is 196. 196. It doesn't stop there. It also says a step further. It is easier for you to do it straight away than finish this one, come and do this one and do this one. And that is why I'm sorting it out one after the other. It is easier for us to just do it on a straight line. The last column now says observed minus expected squared divided by the expected value. So observed, this is observed minus expected, that is 35 minus 21, we have 14. Then the next column says observed minus expected square. Square means that value times that value. 14 times 14, we have 196. Then the last column is said observed minus expected squared divided by expected value. So it means 196 divided by 21. 196 divided by 21 is 9.3, so that I can save our time. 196 divided by 121 is 9.3. It means in 196 you can see 21 9 times, then 0.3. Then the next one says 14 minus 21. What do we have? 14 minus 21, or 21 minus 14. 14 minus 21 or 21 minus 14. 21 minus 14 is 7. And because 14 is coming first, that means it is a negative sign. That means it is minus 7. That means it is minus 7. Then minus 7, minus times minus will give us positive. Then 7 times 7 will give us 49. 7 times 7 will give us 49. 7 times 7 will give us 49. Then 49 divided by 21. 49 divided by 21, we have 2.3. We have 2.3. Then the next one says 23 minus 21. 23, 21, 22. So that means what? 2. Then 2 times 2, we have 4. Then 4 divided by expected value, which is 21. 4 divided by 21, we have 0.2. 0.2. Then the next one says 20 minus 21, that's minus 1. Minus 1 times minus 1, we have what? 1. 1 divided by 21, we have 0.00000 something. Then also the next one says 16 minus 21. If you are trying to do it the opposite way to 21 minus 16, that's 5. But because 16 is coming first, it will be minus 5. Minus 5 times minus 5, you have 25. Then 25 divided by 21, we should have 1 point something. 1.2. 1.2. Then the last one says 18 minus 21. 18, 19, 20, 21. That should be give us minus 3. Minus 3 times minus 3, we have 9, because minus times minus would always give us positive. Then 9 divided by 21 will give us 0.4. 9 divided by 21 will give us 0.4. Adding all this together, adding 3 plus 3, 6 plus 2 plus 4, 10 plus 4, that's 14. Remaining 1, this is 1 plus 9, 10 plus 2, 12 plus 1, that's 13.4. It means our answer, the total summation of summation of x minus x bar all over summation of observed minus expected squared divided by expected is the summation. This is summation of everything. Summation is what? 13.4. 13.4 is 13.4. The summation is 13.4. Don't let's also forget that the next step is to make a decision. And what is the decision process? We said when chi-square calculated is greater than chi-square tabulated, what do? We reject. Then when chi-square calculated is less than chi-square tabulated, we what? We accept. Let's now try to interpret the question. Chi-square calculated is greater than chi-square tabulated. So I'm going to clean this off since it is greater. I'm going to clean this off since it's greater. Then chi-square calculated, that means our calculated value, that's 13.4. 13.4 is greater than the table value is 11.1. And the question says reject the null hypothesis. The null hypothesis says consumers do not have preference. It means that we are rejecting that consumers do not have preference and accepting that consumers have preference in or among the 6 colors of bags that we have. Among the 6 colors of bags that we have. Don't mind me, I know this board is quite small. It's quite small for the graph, but let me still draw it anyway. Let me still draw the graph anyway. Don't forget that we said it is always skewed to the right. It is always skewed to the right. This is 0 points. This is at 0 points. Then we have something like this, a graph that looks like something like this. Then let's say 1 2 3 4 5 6 13, 11 should be at this point. Then 13 should be at this point. 11 should be at this point. Then 13 should be at this point. Don't forget to always draw this graph. It is also equally important. It is as important as all the calculations. I hope you have enjoyed this section. I take us through another illustration quickly before we call it a day. This is another illustration on chi-square distribution before we move to goodness of fits. Okay, a researcher wishes to determine whether there is a relationship between the gender of an individual and the amount of alcohol consumed. A sample of 68 people was selected from the following data, or the following data were obtained, and alcohol consumption, we have gender, we have male and female, then we have low, we have moderate, we have high, we have total. And they said, the question further said that alpha is 10%. Can the researcher conclude that alcohol consumption is related to gender? Now we want to solve the solution now. Solution. But before we go ahead with the solution, I want us to calculate the total for each, because it's going to help us in getting our expected frequency. So let's start. 10 plus 9, that's 19. 19 plus 8, that's 27, if I'm right. 10 plus 9, 19. 19 plus 8 will give us 27. Then 13 plus 16, that's 29. 29 plus 12, that should give us 41, if I'm right. Yes, that should give us 41. This should give us 10, 10, 30, 30, that's 30, then it should give us 41. Then looking at the total here, 10 plus 20, 13 should give us 23. Then 9 plus 16 should give us 25. 25, 4, yes, 25. Then 8 plus 12 should give us 20. Then let's look at if the total here would also give us the total here. This will give us 8, and this will give us 68. Let's see if this will give us 68. So 20, 20, 20. Then this also gives us 68. Then that means the question is right or is logical. And how do we go about solving it? The first step, like we said, is step one is to write out the hypothesis. And the hypothesis says that we want to confirm if alcohol consumption is related to gender. So my first hypothesis will be written this way. You can write it in your own way, but I'm just going to write it in my own way, that alcohol consumption is not related to gender. Alcohol consumption is not related to gender. Then H1, for H1, alcohol consumption is related to gender. Alcohol consumption is related to gender. One is alcohol consumption. We have said that the null hypothesis, the HO, is always stated in the negative form, while the H1, the alternative hypothesis, is always stated in a positive form. Alcohol consumption is related to gender. Then the second step is what? Our degree of freedom. And degree of freedom is what? Our degree of freedom is the formula is C minus 1 into bracket R minus 1. You can write it either way. You can also say R minus 1 is still going to give us the same answer anyway, minus C minus 1. C means column, R means row. So how many columns do we have? Column low, moderate, and high. That means 3 columns. So it means 3 minus 1. Then how many rows? Male and female. Because I was the person that created this total row and total column, so it's not part of the question, and that was why I said let us add it up together. So we have male and female now. Male and female. So how many rows do we have? 2. So 2 minus 1. So 3 minus 1 is equals to 2. The into brackets, 2 into brackets. 2 minus 1 is 1. That is equals to what? 1. That is equals to 1. Then what is our degree of freedom? Our degree of freedom is 10%. Degree of freedom is 10%. I mean level of significance. 2B, level of significance is 10%. And 10% is equals to 10 divided by 100. And 10 divided by 100 should give us 0.10. 0.100 in 10, 0. Then 100 in 100, 1. Then the 0.1 or 0.10 is still the same thing. Then we'll look at our table. Where is my table again? The table will be added to the video. Don't forget. So looking at 0.10, our degree of freedom is 1. This 3 minus 1, that's 2. And 2 minus 1, that's no. Our degree of freedom is 2. Sorry, our degree of freedom is 2. This is 2 minus 1, 1. 3 minus 1, 2. 2 times 1, that's 2. So our degree of freedom is 2. So we are looking at the degree of freedom 2 under 0.10. 2 under 0.10. If I am saying right, it is 4.6. Our answer 2 under 0.10. It is 4.605. 4.605. 4.605. So the next step will be to calculate our test value, and that will be the next. Okay, I've also systematically brought all this information on a single table, and I just want to explain what the table means. Try to always bring it on a table. It's going to simplify your work. That's the best way of solving this, once you bring it on the table. If you want to do it individually, it is not as if it's not possible. Any little mistake would just make us or make you to miss the whole process, but bringing it on the table simplifies the process. And just look at what I did in representing it on the table. I'm a statistician, so I'm very familiar with tables. So if you can learn the process of putting all this information on the table too, it's going to help you a great deal. Okay, this is the gender, this is observed, expected, observed minus expected squared, observed minus expected squared divided by expected. Okay, so what's the first thing I did? I said male low, and that is 10. Male moderate 9. Male high 8. Female low 13. Female moderate 16. Then female high 12. Look at how I'll get the expected frequencies now. This is the shortest cut that I know. There are other processes, but I'm sure with this shortcut we are all good to go. So see what I will do to get for each of my variables. For male low, see what I will do. For male low, how do I get the expected variable? The total on this male is 27, so I write it out. 27. The total on this male is what? Multiplied by 23. The total for male 27. The total for low 23 divided by 68. If you try to work this out, let me bring my calculator so we can work it out together. That will be 27 multiplied by 23. That's 621. 621 divided by 68. Divided by 68. We have 9.13. 9.13. So for my expected now, we have 9.13. I would do the same process for male moderate. Male moderate now, looking at male moderate. What's the total for male? 27. What is the total for moderate? 25. Divided by the overall total, that's 68. So I'm going to do the analysis quickly. 27 multiplied by 25, that is what? 675 divided by 68. Divided by 68, what do we have? We have 9.9. So my male moderate will be what? 9.9. My male moderate will be 9.9. Then I do for the I part. What is the total for the male? 27. And what is the total for the I? 20. Divided by the overall total, that's 68. So I quickly work it out. 27 multiplied by 20, that's 540. 540 divided by 68. 540 divided by 68, that is what? 7.9. 7.9. So I come here to write 7.9. Then I also repeat the same process for the female. I also repeat the same for, don't mind me, I'm a teacher, I'm using my hand to clean my board. I'll wash it after the class. So then for the female, looking at the female low, what do I do? What is the total for the female? The total for the female, the total for the low, that's 23. Or let's start with, we can do it vice versa. The total for the female is 41, then the total for low is 23. 23 divided by 68 divided by 68. What would be my value? That would be 41 multiplied by 23. That's 943. 943 divided by 68. 943 divided by 68. I have 13.9. So I come here to write 13.9. 8.9. I hope we are getting what I'm doing. Then for the female moderate, for the female, the total for the female is 41. Then total for moderate is 25 divided by 68. I work it out quickly. 41 multiplied by 25, that's 23,525 divided by 68. Now equals divided by 68. We have, oh, that a mistake, there's a mistake somewhere. Sorry, 1 minute. 41 multiplied by 25. Sorry. I mistakenly typed something is 1025 divided by 68 equals to divided by 68. Divided by 68, we have 15.1. So I come here to write 15.1. Then the last one is the female I, and female I will be what? The total for female is 41 multiplied by the total for I, 20 all over 68. What do we have? So I quickly also do that. 41 multiplied by 20, that's 820. 820 divided by 68. 820 divided by 68, I have 12.1. So I come here to write 12.1. I hope everybody got how I did the expected value now. So we go back to the calculation. We are in step 3 already, and step 3 says find by chi-square equals to summation of observed minus expected squared all over expected. What is the answer? We have gotten the table value to be our table value is 4.605. 4.605. Then let's get the calculated value now. Let's get the calculated value. So because of my time, I'll try to be fast. So the first one now will be, I'm still going to be using my calculator to work it out. I'm still going to be using my calculator to work it out. 10 minus 9.13. 10 minus 9.13. That's 0.87. 0.87. 0.87. Then 0.87 multiplied by 0.87. I have 0.7569. 0.7569. 0.7569 divided by my expected, that's 9.13 divided by 9.13. I have 0.08. 0.083. 0.083. Then the next one says 9 minus 9.9. 9 minus 9.9. 9 minus 9.9. Obviously 9.9 is greater than 9 by 0.9, so our answer will be 0.9 minus 0.9. Then minus 0.9 times minus 0.9, because it is minus times minus will give us positive, so that will give us 0.81. 0.81. Let me write it out clearly so that we can all see. 0.81. 0.81. Then 0.81 divided by the expected, that is 9.9. 0.81 divided by 9.9. What do we have? We have 0.818. Then the next one says 8 minus 7.9. 8 minus 7.9, that's 0.1. Then 0.1 times 0.1, that is 0.01. Then 0.01 divided by 7.9. 0.01 divided by 7.9, we have 0.001. 0.0001. Then the next one says 13 minus 13.9. Obviously 13.9 is greater than 13. We have minus 0.9. Then 0.9 times 0.9 minus 0.9 times minus 0.9, we have 0.81. Minus 0.9 times 0.9, we have 0.81. Then 0.81 divided by 13 divided by 13.9 divided by 13.9, we have 0.0553, 0.005, no, 0.058, 0.058. I'm trying to cross check so that I don't make mistake. Then the next one says 16 minus 15.1. That's 0.9 again. 0.9. 0.9 times 0.9. We have 0.81. 0.9 times 0.9. We have 0.81. Then 0.81 rather. 0.81. 0.81. 0.81 divided by 15.1. 0.81 divided by 15.1, we have 0.054. 0.054. Then the last one, obviously 12.1 is greater than 12, so 12 minus 12.1, we have minus 0.1. 0.1 times 0.1 is already on the board, but I'm just trying to do a further confirmation. 0.01. Then 0.01 divided by 12.1. 0.01 divided by 12.1, we have 0.001. 0.001. Don't forget, we are trying to look for the summation of this. So adding up this one now, adding up what we have on the board, adding up, the first one is 0.083 plus 0.818 plus 0.001 plus 0.058 plus 0.054 plus 0.001. So we have our summation now is 1.015. 1.0. So our answer here is now 1.015. 1.015. The fourth method says make a decision. Make a decision. Make a decision. And the decision says when t calculated is greater than when chi-square calculated is greater than chi-square tabulated, what do? We reject. Then when chi-square calculated is less than chi-square tabulated, we accept. Okay, bringing our answers now. Chi-square calculated is what? 1.015, and chi-square tabulated is 4.605. So it means that chi-square calculated is lesser than chi-square tabulated. So it means we accept that there is no relationship. The question says there is no relationship. Our hypothesis states that there is no relationship between individuals' gender and alcohol consumption. So our answer therefore is that the researcher can now say there is no, or there is, the null hypothesis said there is no relationship between gender and alcohol consumption. The alternative hypothesis said there is a relationship between individual gender and alcohol consumption. Now we are saying that we should accept the null hypothesis that says there is no relationship between gender and alcohol consumption. Then let's try to draw our graph now. Let's try to draw our graph. The fifth method, we said, it always starts from 0 and it is always a right tail test. It is always a right tail test. This is 0, let's say 1. This should be 4 around this place. 4.06, 4.065. I want to see what the graph looks like. 4.065. So I'm going to shade for us to see the critical region. I hope everybody understands. Okay, we move to the goodness of fit test now, so that we would know the difference between chi-square and goodness of fit test. Okay, we look at the test of goodness of fit also using chi-square. They are very similar. The only difference is how to get the degree of freedom, and I'll get to that in a minute. We said, what is the objective? Is to test the distribution for goodness of fit. Goodness of fit, if it actually fits a specific pattern like that of the chi-square. And what are the steps involved? 1, state the hypothesis. Then 2, the degree of freedom. For chi-square, the degree of freedom is C minus 1D, then R minus 1, colon minus 1, then rho minus 1. But for the degree of freedom for a goodness of fit test, it's just K minus 1. Most times we are only giving rho, no columns. Then we said compute the test value, that is chi-square is equals to summation of observed minus expected square all over expected. Then make a decision. Then the 5th part is to draw a graph. This is a simple illustration. Let's read it out. I try as much as possible not to give us just straight questions, and that is why I brought this question up, so that we can also understand and know how to read our question in case we have this kind of situation in places of work or different fields in life. This illustration says a researcher read that fire-related deaths were distributed as follows in a particular town. 74% were accidental, 16% were homicides, and 10% were suicides. In a particular town, there were 68 accidental deaths, 27 homicides, and 5 suicides during the past year. At alpha is equals to 10%, test the claim that the percentage are equal. The first thing, and we know that the first thing to do is to write the hypothesis statement. So the first step is HO. Test the claim that the percentages are equal. So HO is the percentages are not equal. The percentages are not equal. The percentages of firearm related deaths are not equal. Are not equal. It's always stated in negative format. And not equal, in a negative form rather. Then the percentage of fire related deaths are equal. The percentage of fire related deaths are equal. Then 2, the degree of freedom. Looking at the degree of freedom from the board, how many variables do we have? The first one is what? Accidental. The second one is homicide, and the third one is suicide. So there are 3. So it means K minus 1. So it means 3 minus 1. 3 minus 1 is 2. Then don't forget that we said our level of significance is 10%. 10% is 0.10. So we are looking at 2 under 0.10. Let me get my table so that we can quickly get what the answer is. We are looking at 2 under 0. It's still the same value that we got, 4.605. 4.605. You can remember we got this answer previously, 4.605. So I clean and show us the other solution. I take the question again because I've cleaned the board. That's why I'm looking at my book. A researcher reads that firearm related deaths for people were distributed as follows: 74% were accidental, 16 were homicides, and 10% were suicide. In our district, don't forget that we said any calculation, in solving this question, observed are always given straight away. You don't need further calculation. But when you have a further calculation to do, it means it is expected value. I read the question again so that we can understand. A researcher reads that firearm related deaths for some people over a period of time were distributed as follows: 74%, because they said 74, it means it is over 100. A calculation is involved. 74% were accidental, 16% were homicides, and 10% were what? Were suicides. They said in that particular town there were 68 accidental. It means for our observed is 68. Then they went further to say 27 were homicides. 27 were homicides. Then 5 were suicides. Any question that you require a further calculation, it means that is the expected value. But any question that you are given straight away, anything that you can deduce straight away, it is your observed value. I hope everybody means what accidental means. It wasn't deliberate, it just came. Then homicide is when somebody is killed. Then suicide is when somebody kills himself or herself. God forbid, we will not kill ourselves or ourselves in Jesus' name. So then we will not see people to kill us too in Jesus' name. Then we will not have accidental deaths in the mighty name of Jesus. So as I was saying, okay, how do we now work out the expected value? They have given us in percentage before and already that this, if you add all this together, it will give us 100%. So it means for accidental is 74%, for homicide is 16%, and for suicide is 10%. Working it out. So let's take a look at the next thing to do on the board. What is the next thing to do from an analysis on the board? I'm trying to work out my calculator. The first one says 68 minus 74. 68 minus 74, that's minus 6. Minus times minus will give us plus. 6 times 6 will give us 36. I've always suggested that you do it straight. Don't finish this one and finish this one and finish this one. It will take a lot of time, but once you do it straight, you know you have finished one, then you are sure of the answer. Then what else do we need to do? 36 divided by the expected value, that's 36 divided by 74. What do we have? We have 0.486. 0.486. Then the next one says 27 minus 16. 27 minus 16 is 11. 11 times 11 should give us 121. 11 times 11 should give us 121. Then 121 divided by the expected value, which is 16, should give us 7.563. Then the last one says 5 minus 10. 5 minus 10 is obviously minus 5. 5 minus 10 is minus 5. Then 5 minus times minus is plus. 5 times 5 will give us 25. 5 times 5 will give us 25. 25 divided by 10. 25 divided by 10 should give us 2.5. I'm just adding the zero. The zero, if you don't want to add it, you might not add it. What is our total? Because we are looking for this summation. I quickly add up. The first one is 0.486 plus 7.563 plus 2.500. That is, our total here is 10.546. 10.546. 10.546. Okay, then the next thing to do is putting it out into our equation. The third step says what summation of expected observed minus expected squared, observed minus expected squared all over expected, and our answer is 10.546. Then the fourth rule says make a decision. The fourth rule says make a decision. Make a decision, and we already know what our decision making process is. We said when chi-square calculated is greater than chi-square chi-square tabulated, what do? We reject the null hypothesis and accept the alternative hypothesis. Since chi-square calculated, what is chi-square calculated? 10.546 is greater than 4. We add 4.605 from our table that time. What do? We reject the null hypothesis. Reject the null hypothesis and accept the alternative hypothesis. Accept the alternative hypothesis. And what does the alternative hypothesis says? The non hypothesis says the percentages are not equal. The percentages are not equal. But the alternative hypothesis says the percentage, the claim that of that percentages between accidental, suicide, and homicide are equal. So we are saying now that our answer now says reject the null hypothesis that says the claims are not equal, then accept the alternative hypothesis that says the claim of fire related deaths of people in this distribution are equal. The claim of fire related debt in this distribution are equal. Then the last point is to draw out our graph. Our graph is always to the right. It is always a right tail scale. It is always a right tail test, and starting from 0 is starting from 0.4, then 10.546, shading this portion to know the rejected and the critical region. I hope we have, by the time you are watching this video, that you will have learned one or two other things to add to your statistical knowledge. Please don't hesitate to send me your questions, and if you have any topic you want me to also look into that I have not looked into, please also put it in the comment section below. I will be expecting your comments. I'll be expecting your reactions to this new video, and I believe God will bless you and bless you and bless you as you watch my video, you share and you subscribe. Thank you.